Yeah, I know that it's lots of stuff there. You're busy, but thanks a lot for just coming to see the presentation. Guys, now we are having
to be here.
Oh, yeah, thanks a lot. Thanks. And now, guys, today we are gonna finish and wrap up all the lectures which we had for the electron for all types of the microscopy.
Yes.
We started with this champion there, talking about two-photon excitation microscopy. Then we went to the Jack to talk about the light microscopy, and also Andy talked about X-ray microscopy, and now here is this champion now talking about the electron microscopy. Then essentially by doing that, tomorrow you are ready to just go to the field trip at the Medical Imaging Center at the University of Toronto, and you're equipped with all the things which you had to know then. Yeah, then BK, please take the stage.
我要重新来一遍，是不是？Okay, so I'm BK, and today my topic is the electron microscope. Okay, so this is my content. So first of all, we are talking about the history of the development, and then it's the overview of the EMS, just like kind of the electron beam for the the basic theorem for the electron microscope, and then it's talk about the resolution and the wavelengths, and then it's the advantages and the disadvantages, and the next part is the what different types of the electron microscopes, and we will talk about their different constitute, and then is the how to prepare your sample. And then I will show you guys a video about the application of the microscope. Okay, about history. In 1926, we have the electromagnetic lens at the first time, and then 2 years later, the first electron microscope is be discovered, developed. And then maybe 9 years later, the first scanning electron microscopes have to be used. And do you know this company is a big company for maybe Siemens? Yes, a German company. Yes, for a lot of business like your TV or some air conditioner. A lot of the electronic machines
They have
produce
electric power.
Yes, yes, and
BK, are you just marketing for the Siemens or?
Oh yes.
You're promoting the
They pay
Siemens,
for
huh?
me. Yeah. So in 1938, the first commercial electron microscope is we have the first one, and then maybe next year we have the first transmission electron microscope. So this the scanning and the transmission are two different types of the electron microscope, and we will talk about later. Okay, so it's the overall view of the electron microscope. So the basic series is they have a electron source to launch many of the beam of electrons to through the sample that you have, and to see the structure of your sample. Maybe mostly it's for like crystal things, but it's also for some biological samples, like the cells, the metals or crystals. Yes. And then is the wavelength and the resolution. The resolution in microscope is limited to about 1/2 of the wavelength of the illumination source used to image the sample. And then it's normally about the light microscope only about 200
Nanometer.
nanometer. But actually, for an electron microscope, it can alert to maybe just 0.1 nanometers. So it's pretty different as the light microscope. But the serum is pretty similar. and we will see later.
So just in that case, if you just
Okay.
please go back to the previous slides, based on all those techniques which we have learned, which technique BK offers the best resolution when you just want to just probe a microorganic, I should say, structure?
I think is the electron.
Electron.
Yes.
You just get the resolution, the best one, it just gets to 0.1. And how about this one?
It's
This is for the
light.
light microscope.
Yes.
And how was for you for the 2 photon?
50.
50. Then in that sense, the electron microscopy offers the best resolution
Yes.
for, yeah, that's
Because
very
it
interesting.
depends on the wavelength.
That's right.
Actually, like normally the light, the wavelength is higher than the electrons.
That's right.
So that's why the electron microscope have the lower the wavelength than the.
That's what you mentioned, 1/2 of the wavelength of the source.
Yes.
That's for example, if you have, let's say, the optical microscopy, the half of the wavelength of the visible light is the limit, the maximum
Yes.
limit of the resolution.
Yes.
But the electrons, I should
Yes,
say,
because
they has shorter.
Very short.
The half of the wavelength becomes much smaller.
Yes.
That's why you get to that very small scale for the resolution.
Yes.
Very interesting. Very interesting. Thanks.
And then we'll talk about the pro and cons of the EMS. The EMS is the electron microscope. So for the wavelength is of an electron is 100,000 times shorter than the visible light photons, and have the it has the higher resolving power than the light microscope, and then also can
Reveal.
review the structure of smaller objects. Means that your specimen could be smaller than the light.
That's right.
Okay, and disadvantage is it's quite a bit hard to like visible the live samples. You have because for the electron microscope, if you want to see your sample, you have to be welcome. 真空值
Volume.
welcome
Vacuum.
vacuum
Vacuum.
welcome.
Huh?
Vacuum.
No
有
worries.
点问题。
It took me a long time to learn what is a vacuum. No worries.
Welcome. Environment to in your the sample chamber because it to avoid some other substances
That's right.
to have to make your structure have some wrong.
That's right.
So but another disadvantage is it's difficult to analyze the image when the lake for the structure in the specimen. It means it's quite a bit hard to see the the
Specimen?
the specimen is pretty depends on what kind of specimen you have. But if you have like the with water or some other, it cannot to be pure.
But what is the connection, BK, with that thing that you just want to visualize? For example, microorganel within the scale of the nanometers. But why the structure of having that specimen have an impact on the electron microscopy resolution? Then? Why you need a structure in that specimen?
You can see more like species specimen you have. I mean, like it can be more for not for biology, but it's for physics, for like some crystal something that you can't see by the light microscope.
Does it have anything to do with the diffraction which you expect to have it as a result of, I should say, the electrons passing through the object?
Yes,
It gets
maybe
diffraction
have
due to the structure which the
yes,
object
if you damage the sample you have because the beam of electron has the heat energy, so maybe it can change the structure of your specimen.
Super.
Nice.
Okay, next page.
And what is that temperature then? If you please go back to what is that? 150 centigrades. That's freezing. What is that temperature coming from?
Like if you have the it's basic on the biology, right? So if you have the cells you want to see, but the electrons have it's super hot, so it's made not to destroy the cells and damage your sample. It's similar as this one, yes.
That's right. The high energy nature of the electrons.
Yeah, so it's normally just for those crystal or metals. And then we have mainly two types of the electron microscope. The first one is the transmission electron microscope. It's just the basic on through your sample to see your structure. But for the scanning one, it's just to scanning the surface of your sample. So which means if you have the TEM, you only can use this very thin sample to see. But if this one can see the surface of your sample,
right.
it's more complicated for scanning.
Okay, producing very. Oh, interesting. Very interesting.
Because this one is for maybe one side, but the TEM only for one point, and to close this point, means pillar to see this part. Yes.
Then the concepts of the resolution that you talked about, and it was an order of the 1 nanometer. Is it going to be relevant for the transmission or the scanning transmission of the microscope? Because
it's about scanning transmission.
not about the transmission.
Yeah, it's just to through the sample. Now for this one, just to scanning the surface. Yes, it's quite different.
That's
For the TEM, it's like the older one, so it's just like a little bit hard to. But it's for different way to use. Like if you want to see your samples the inside structure, you have to use the TEM.
That's right. Interesting. Nice. What?
Okay, so the constitute. So for the scanning one, we have maybe mainly part the system. The first one is the electron optical system, like this whole part from maybe electron gun and something. And then it's for the sample. If you have sample, you have to have a chamber to keep your sample as a welcome system. And then it's your power system to how to offer the power to your machine, and then it's the software like to connect to your PC or your computers to check out the image. Okay.
No, don't. Just go back, please.
Go back.
Interesting. Guys, look at that. Look at that. The electrons all coming through the various lenses.
Yeah.
But look at that. This is a sample there. And you have an X-ray detector.
Yeah.
Who can tell me what happened there? We have the beam of the electrons, but at the end we have something which detects X-rays, which it seems that they are reflected back from the samples under the microscopy. Why the X-rays happens there?
To reflect the wave, so we can see the image.
No, I get it, absolutely true. But you're looking for, let's say, these are just the electrons, but we expect to see an electron rays. But why do we have X-ray? How the X-ray got generated? Where did it come from? The aliens.
Yeah.
Ask Andy.
Andy has an X-ray microscope.
Andy knows that.
But tomorrow when you just go for the lab, you're going to talk about, you will see that there, but that's why the X-ray generates. It's when the electrons, they are just traveling with the high velocity, whenever they change the direction as a result of, I should say, acceleration, or changing the trajectory of their movements, as a result, the X-ray gets generated. That's essentially how the X-ray gets generated. High-speed electrons change their projection. They just get, and you see that these electrons, when they got here, they get scattered.
Yes.
They comes back, and those scattered electrons generates those X-rays.
Like we observe.
That's right. And you have these ones. Which signal goes to a scanning generator? Which signal? Which signal goes there? It comes from
The
secondary electronic detectors.
Yes. It's two signals. One is from this lens,
That's
and
right.
then it's from the reflector.
That's right.
You have to make like double checks.
That's essential. We have different detectors. The first one is you get the X-rays, which you do not need them. It's the byproducts of the electron microscopy. And these electrons, they just got reflected back. They got detected by they call them back-scanted electron detectors. You do not need them. But you only need those electrons which are just reflected back from the sample, for example, from the cell, and you get all the information which you require from these secondary electron detectors, because all the way for processing. Yeah, super, thanks.
Yes. Okay.
Whoa.
So this is the electron optical system. So this is a system to the main part of the microscope. Like you have the electron gun and your lenses, and this part is the chamber of the specimen. So to see it's super complex for the lens and how to constitute the inside part. So we have to know it has a electron source and the lens, and then is the place for your sample.
That's right.
Okay.
Interesting.
And then is the welcome system. It's quite a bit hard to see and to comprehend. And so it's the system to keep you have to know is to keep your sample. It's because there was some like other objects or some other substance to mixed with air or some something. So it's more easier to see your image. It's for your sample. Okay, next. So for the sample preparation, so we have the biology. If we have one biological sample, so we have to avoid the heat to destroy them. So we have some steps to do that. So this is the step. So the first one is the harden. If you have your sample, you have to use your some chemical liquid to harden the sample, and then use some garlic acid to stamp the fat. It means doing this make your fat have some color. So that means you can see this part is fat, and then is the freeze. This normally to without the water. It's quite like the to make the water free. So like for the ice is not water, just like the crystal, and then is the make some color on your samples. It's easier to see what the structure of your sample. And then it's cut the sample to very thin slice by normally we use the diamond knife.
Yeah.
It's hard to cut. It's easier to cut because your sample is already water free, so it's super hard to cut or to make some slice the thing you like. And then we usually use the heavier atoms such as the lead or
Uranium. No,
Uh,
uranium. That's the heavy.
Yes,
That's
very
really
heavy kind of the atoms, to make the higher ability to scatter electrons, the lighter atoms, and it can therefore be used to increase the contrast. And then it's for two different types of microscope. For TEM, the samples must be cut into very thin, close sections, maybe 100 nanometer or thinner, using the ultra microtome, allowing electrons to pass right through the sample. And the sample are treated with heavy metals to increase is same as the last step. With heavy metals to increase the level of contrast in the final image, because on the surface you can, if you have the those heavy items, you can easily to see the inside of your specimen. And for the SEM, the sample are coated with a thin layer of metal. It's quite the same as the TM, right? Just to easier to see your to have to like reflect the beams. It's more easier to reflect, so you can see the more clear image. And it's similar as the TM, just have some color to reflect. Okay. And it's the fluorescence. It's quite hard for for me. Like for the
It's hard for me either.
yeah, well, so for the one image, so the neuroscientific field has been a main driver for development of 3D microscope techniques regarding volume image. And scanning electron microscope offers new
Insights.
insight into the organization of cells and tissues by volume image method. And this disadvantage is restricted to relatively small tissue volumes.
Give us can you please go back to what is that picture? That's the neuron, huh?
Yeah, that's the
Is it by
neuron.
electron microscopy?
Yes, behind you can see the like you have the base of the to keep your sample is like the electron,
That's right.
like the
Interesting.
motherboard or something.
Guys, please look at that. We can just talk to that tomorrow when we are at the field. Look at that. All the techniques which we saw so far, the image of the organelles inside the cell which you saw, it was a flat 2D image. For example, 2-photon microscopy or optical microscopy or X-ray microscopy, they all gave us a flat image of the organelles. But look at this one. Based on the 3D microscopy of the electrons, you have a 3 dimension. You can see some structures of the neurons. You see, it has some depth, which is unique to electron microscopy. And tomorrow, please remember that concept. So you can ask a lot of questions about that generation of a 3D image of, for example, a neuron. And that's very unique. And isn't that beautiful, guys?
Yeah.
好烦人，后面的我已经完全不知道说啥了。Okay, so this is the last part we will talk about. It's the volume electron microscope. So survival methods for volume electron microscope have been
Established. Established?
established.
That's
Yes.
right.
Yes, and classically, the serial ultra-thin section has been prepared using a ultra microtome, followed by the by manually placing them onto upper copper glass for image in transmission TEM, and limit by the accessible volume to a maximum of 1 times 2 millimeters. Instead, image in SEM for samples exceeding this size.
Interesting. What are those pictures?
What is that?
They're very interesting stuff. Especially when it goes through these ones. Wow. What's happened there?
It depends on your resolution.
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 That's right.
Yes. Like At the beginning, you can see the test card of the your sample, and you just make it bigger and bigger, so you can see the different, and you can use by your software to have the 3D model.
Oh, very interesting. Guys, tomorrow, remember, that's going to be a very good, I should say, thing to, when we just use the microscopes to see how these, I should say, 3D modeling of the organelle, for example, of a neuron get generated.
Yes.
Because that's only unique for electron microscopy. We didn't see that in the optical
That's
or the
biggest
X-ray.
That's
or
biggest
2D.
question. That's
That's
biggest
right.
question.
That's your quiz for tomorrow. Then.
Okay.
Yeah. Yeah, next slide, please.
And this is a video that
Lonely.
好像是可以做一个老长，你可以1.5倍速看，可以7、8场。
2倍速。
1.5倍速，1.5倍速。
This is electron microscopy, huh? Wow.
What is that?
Fruit fly.
Oh,
Human thumb. What? Oh. This is toothbrush.
toothbrush. What is that?
就是一根毛，用亚当上的一根毛。
Sea water.
What is that?
Oh, embryo. Oh my goodness, that's
Beautiful.
mind blowing.
Butterfly. Cancer
Cancer
cell.
cell. Oh my god, I'm fascinated in that field. Blackboard. Sheet number. Oh my god, look at that.
Wow.
How to
Cigarette paper.
Cigarette.
Up here. Oh, fly.
Scary.
That's mine. Oh.
Leaf.
跳蚤，不利跳蚤。Flower pot order.
What? What is that?
Wow. Black pepper. Black pepper.
Oh wow. Retina is for human eye bag.
Fertilization.
Picture. Wow. Marijuana.
Marijuana. Who is marijuana?
大。
Oh. Oh, this is still micro crack.
It's like a mountain.
That's right. What is that? Like
C6.
Oh yeah.
virus. Oh my god, the virus looks like that.
The
I don't know. Oops. Blood cells.
Sugar crystal.
Sugar crystal. Wow. Self-assembling plastic. What is that?
Snow crystal.
Super.
Oh my goodness.
Surface of the.
What is that?
What is that? Mega.
Sci-fi monster.
Mega. What is that?
What is that? The shark ski.
Sharp skin.
Oh, what is that? Artificial. Oh, I can't even pronounce it. Tooth.
I can see. Wow.
Oh, the oh, shit. Oh my god. This baby's everything.
斑马
Velcro.
wood
Woven fabric. 更丑。发了好了。Sub.
Oh, is it done? Oh, it was very amusing.
That's it. That's it. That's
Is it all?
yes.
Thank you very much for your spectacular, I should say,
Super.
presentation.
Yeah.
I really enjoyed it myself. Thanks a lot, guys. Thanks, Mo, for just coming.
我裂了，
Spending
好
your
难
time. And thanks. And just guys, I think before we leave, if you don't mind, just take a group picture all together, if you don't mind, huh?
Yeah.